Granted memory was incorrect for the second query. Best practice guideline calls for keeping statistics up to date for granted memory estimation to be correct. But we did update statistics with full scan right after creating the table and inserting all of the rows. The best practice guideline will further call for reorganizing or rebuilding indexes, checking database consistency, performing regular backup, and creating one TempDB data file per core on the same volume. Let me tell you, none of that will help you here. You got to understand the real problem and find the solution. That is what my workshop is all about, to explain you the real world issues and solutions, not the basics. Have you been to a training where the instructor claims the training is advanced and then digs into the basics like cluster, heap, non-cluster indexes, database engine tuning advisor, and SQL profiler? My 3-day level 400 Microsoft SQL Server performance monitoring and tuning workshop is a truly advanced workshop. Basic SQL Server concepts will not be covered. Prior basic SQL Server experience is necessary to participate in my workshop. Even if the majority votes, I will not cover basics. I got 6 days of content and I delivered the best in 3 days. My workshop is not a result of reading books or attending other trainings. It is a result of real world consulting engagements. I am not a so-called all-in-all expert. My expertise is only on SQL Server performance monitoring, tuning, and troubleshooting. I know some of you have doubts. Why creating one TempDB data file per core on the same volume does not help in this case. Let me explain. It is best to avoid sort spills over TempDB. I know in some cases it is not possible to avoid sort spills over TempDB. Let's say you want to sort 10 GB of data, but the system has only 8 GB of memory. Sort will spill over TempDB. It is not possible to avoid sort spills over TempDB in such cases. Well, in that case, creating one TempDB data file per core on the same volume could be counterproductive to performance. Yes, I have your attention. Could be counterproductive to performance. Of course, you want to see an example, and I will show it to you. My workshop is all about showing you. There is no PowerPoint slide to preach you the best practice guidelines. I will show you and you can see it, and there is no better way of learning than this. Let's see how many data files I have for TempDB. Let's say use TempDB SP help file. My TempDB database has one data file on the C drive and it's 1 GB in size. Let's execute this query in the test database with predicate 100,000. It's the same query. Instead of predicate 3057 or 3058, we have 100,000. Let's execute this query. First time the query might be slow because the data might not be in the cache. So let's execute it again after this query completes to see the performance numbers while the data is in the cache. Right now the query takes 12.2 seconds to complete. Let's execute it again and let's see what is the duration. The elapsed time is 8.5 seconds. I have 4 cores. So let's add 3 more data files to the TempDB database on the same volume, that is the D drive. Let's select these 3 alter database commands. Let's execute. Let's restart the server so we have predictable performance. Let's execute this query to see how many data files we have for TempDB. There you can see there are 4 data files, all of them 1 GB in size on the same D drive. Now let's execute this query with predicate 100,000. First time the query might be slow, again, since the data might not be in the cache. Our initial query, when the TempDB add 1 data file, completed in 12 seconds when the data was not in the cache. This query is taking quite long, 31.9 seconds. Let's execute this query again. This time the data should be in the cache. We already crossed the 8 seconds, 8.5 seconds, and we are still waiting for this query to complete. This query takes 28 seconds. Increasing the number of TempDB data file in this case actually reduces the performance. That's what I mean by could be counterproductive to performance. You might think on a RAID or on a SAN it might perform better whether one has one TempDB data file or one TempDB data file per core on the same volume. Of course, my server has single CPU with 4 cores and 4 direct attached disks. No RAID, no SAN. I have to tell you, I have some past workshop attendees who are now good friends, willing to volunteer and learn. It is a win-win situation. I get to observe the behavior of SQL Server on various system configurations while they get to learn some real-world performance tuning techniques. I provided the table creation script and the query to test on a SAN and on a RAID with one TempDB data file and with 16 TempDB data files on the same volume. Since the server used to compare performance at 16 cores, the response from Harald, a sincere student of mine who compared one TempDB data file with 16 TempDB data files on the same volume was, I have done some testing and yes, 16 files are worse than one TempDB data file. I have to tell you, I understand is the customer's pain. Personally, I will not use the term worse. I would say non-optimal. It is not because I don't personally feel the pain. From my point of view, it is quite slow but does not deserve the description worse. I reserve the word worse for other scenarios. Let me tell you, in some cases, there will be no extra penalty for creating one TempDB data file per core on the same volume. It all depends on the SAN and the RAID volume configuration. From the test results on RAID, the performance difference was minimal, but still, one TempDB data file was slightly faster than 16 TempDB data files on the same RAID volume. I know the best practice guideline calls for one TempDB data file per core on the same volume without giving any consideration to how the backend, SAN or RAID is configured. You know, the best practice guidelines of creating one TempDB data file per core on the same volume is to reduce the allocation resource contention for TempDB. Even SQL Server Best Practice Analyzer asks you to create one TempDB data file per core. Allocation resource contention in this context means contention during creating and dropping many TempDB objects concurrently. But think about it, how many percentage of customers have allocation resource contention compared to sort warnings event occurring in their SQL profiler? From my experience, I can tell you, sort warnings occur very often compared to allocation resource contention, which is quite rare. Most customers will never observe allocation resource contention. Based on the knowledge of few known issues, providing best practice guidelines is not useful. One thing I do in my workshop or consulting practice is not to throw best practice guidelines at the customer without a balanced explanation, especially not over a PowerPoint slide as a bullet point. Next time, when someone throws a best practice guidelines at you, ask them, where is the proof? Ask them, how much percentage gain, positive or negative, you can expect. Ask them if they can demonstrate it. Unfortunately, in the IT consulting business, there is no money back guarantee for protecting yourself against these kind of non-optimal best practice guideline recommendations. It is your responsibility to educate yourself in the right way to make informed decisions. You know, when sort spills over TempDB, the IOs are pretty sequential. By creating 4 files on the same drive, you make the sequential IOs into 4 streams of sequential IOs, which is not really sequential anymore. So if you got 16 TempDB data files on the same volume, due to 16 cores, you have to make sure your SAN or RAID is configured in such a way it can efficiently handle 16 streams of sequential IOs. I like to answer real questions and not just answer simple questions like what a CPU core or hyperthreading means in the context of 1 TempDB data file per core on the same volume, which is how many trainings go. Unlike other trainers and instructors, I believe developers and administrators are capable of understanding and developing deep SQL Server skills. They are waiting for an opportunity, and we are here to provide them that opportunity and that knowledge. I know you want to see it, and I will show you. That's what learning is all about. I will show you what I mean by 4 streams of sequential IOs. Let's go to the terminal server session. Let's start the file monitor. I have a filter to look for activities over files on the D drive ending with tempdb. Let's start the file monitor and let's execute our query. Let's go to the file monitor. We can now pause it. Let's go to the top, and there you can see SQL Server is writing to tempdb 432, tempdb 432. So it is writing one file after other, and if you see here the offset is the same within the file. So you got 4 files. SQL is writing a little bit here, little bit here, little bit here, and little bit here. That is what I mean by this IOs are not sequential anymore. Let's now drop the additional tempdb files. Let's drop the additional tempdb files. Let's restart the server. And let's make sure we do have only one data file for tempdb. Use tempdb help file. Yes, we have only one data file for tempdb. Some of my customers use top in their queries. I know many customers use top without knowing its impact. Let's execute a query that selects top 100 rows from this table where C1 less than 30,000. Let's send the results to text. Since we have 100 rows, we don't need to use variables. Let's execute this query. First time the query might be slow because we just restart the server. Let's execute the query again. Yes, the query is fast. It's completing in 182 milliseconds. Let's execute again, 186 milliseconds. So 182 to 186, the query completes. Let's now change top 500. Let's execute this query. The query takes 1.9 seconds. The query is very slow. Looks like top 100 is very fast and top 500 is slow. Let's narrow it down. Let's say top 300. Let's execute this query. Top 300 is still slow. It takes 1.6 seconds. Let's say top 200. Let's execute this query. 1.4 seconds, still slow. Let's choose top 150. Let's execute this query. 1.4, still slow. Let's choose top 120. Let's execute this query. The query is still slow. Let's choose top 110. Let's execute this query. 1.3 seconds. Let's choose top 105. Let's execute this query. 1.3. Let's choose top 103. Let's execute this query. It's still slow. Let's choose top 102. Let's execute this query. There you can see the elapsed time, which is the duration, is 1.3 seconds. Let's choose top 101. The query takes 1.4 seconds. 1.4 seconds. Let's choose top 100. You can see the query is very fast. 186. milliseconds for top 100 and 1.386 seconds for top 101. The reason top 101 is slow is because top 101 query in this case spills to TempDB. Let's go to the profiler. Let's connect to the SQL Workshops instance. Let's choose blank as the template. Let's go to the event selection, errors and warnings, and let's choose the sort warnings again. Let's run the profiler. Let's go to Management Studio. Let's execute the query with top 100. Let's execute it a couple of times. Let's go to the profiler. There you see there is no sort warnings. Let's go to the Management Studio. Let's change the top to 101. Let's execute the query. The query is slow. Let's execute it a couple of times and we will look at the profiler. There you can see there are sort warnings. This shows top 101 in this case spills to TempDB. You might ask, why can't I optimally select more than 100 rows with top? May I ask you a question? Why do you want to order by and show more than 100 rows? Usually users don't read so many rows, especially the 101st row. It is too far from the first row. In addition, there is no place for the 101st row in the monitor to display it. Just joking. I am with you. I am fully with you. I can feel the pain of the customer. I will help you to make selecting more than top 100 rows perform as good as top 100 for a developer, a DBA, a consultant. It is important to understand the issue. The resolution will come naturally. It is my mission to help you get there. Now let's discuss how to address this issue and make the second query execute faster. For that, you have to understand how SQL Server allocates memory for queries. I know this has been a long session. I like to teach you how to catch a fish rather than giving you a fish. If you understand how to identify the issue and the reason for the issue, I believe you can solve many issues on your own. As an instructor, I will give you all the necessary information you need to know in order to successfully monitor and tune SQL Server performance back at your work. My goal in my workshop is to give all the knowledge to the attendees so they can solve the issues on their own. I do not promote my performance troubleshooting consulting services in my workshop. I think it is unfair to provide half-cooked information to show off one's knowledge and then ask the customer to pay for performance troubleshooting consulting services. Let's look at the execution plan. Let's go to Management Studio. Let's execute our query with predicate 3057, the query that executes fast. Let's execute this query, include actual execution plan, and let's execute this query. There you can see in the execution plan there is clustered index seek, sort, and select. If I move the cursor on top of the sort, there you can see estimated number of rows is 3056.98. The estimation is quite good. Estimated row size is 2015. Our table has 3 columns, integer, integer, character 2000. So the estimated row size seems to be good. And for predicate 3057, the query completes fast. Looks like the estimated memory is good enough for SQL to do in-memory sorts. Let's change the predicate to 3058. Let's execute this query. Let's look at the execution plan. When I move the cursor on top of the sort, there you can see estimated number of rows is 3057.98. Again, the estimation seems to be good, and the row size is the same, 2015, and should be good for the second query. But unfortunately, the estimated amount of memory is not good for the second query. Let me create 2 new tables. Let's create table 7 car. This table has 3 columns. Column 1 integer, column 2 integer, column 1 is the primary key, column 3 is character 2000. And we got another table, table 7 bar car. Column 1 integer primary key, column 2 integer, column 3 is varchar 2000. Let's go to the test database and let's create this table. And let's insert 3000 rows into this table and finally update the statistic with full scan. I copy the rows from tab 7 car into tab 7 varchar, so we have same amount of data between these two tables. Now let's set statistics time on and let's execute the first query, which selects from tab 7 car order by C2. This query completes in 13 milliseconds. Let's execute it a couple of times, 12 milliseconds. The query takes anywhere between 12 and 13 milliseconds. Let's execute this query that selects from tab 7 varchar. This query takes 250 milliseconds. This query is 10 times, more than 10 times slower than the first query. In our case, the data is the same across these two tables. Let's look at the execution plan. Let's execute this query with include actual execution plan and let's inspect the execution plan. There you can see clustered index scan, sort, select, clustered index scan, sort, select. The execution plans are very similar. According to SQL Server, relative to the batch, the first query is going to cost 50% and the second query is going to cost 50%. But unfortunately for us, the second query is more than 10 times slow. Let's take a deeper look at the execution plan. Let's move the cursor over the sort. There you can see the estimated number of rows is 3000. Estimated row size 2015. We are familiar with 2015. We have seen this before. Let's move the cursor over the sort of the next query. There you can see estimated number of rows is again 3000. Estimated row size is 1019 bytes. Looks like SQL Server, the optimizer, estimates half the amount of memory for a varchar based column. Let me tell you a story. Once upon a time, there was this Empress Maria Theresia, the first and only female ruler of the Austro-Hungarian Empire. Empress Maria Theresia is also known as Mother of Austria, not just because she had 16 children. It is for her financial and the educational reform policies she introduced for her citizens. I suggest you check out Wikipedia if you are interested. Austria is a beautiful country and we are sure you will enjoy a visit to Vienna. Imagine 16 children on the dining table and at the same time being the ruler of an empire. That's a lot of work. Well, let's get back to the real story. Let's say Maria goes to a bank and asks the teller, let's call him Tom, the teller. She asks for overdraft protection. Tom asks Maria for her paycheck and Maria shows her pay stub, which says she earns a fixed income of 100,000 euros per month. Tom keys in some numbers into his computer and tells Maria that her overdraft protection limit is now set to 100,000 euros. Then comes our developer. Let's call him Dave. Dave the developer. The self-employed developer who earns up to $8,000 on good months. In other words, a variable character column which stores up to 8,000 characters. Dave overheard the conversation between Maria and Tom while standing in the line. Dave asks Tom the teller for overdraft protection. Tom, after inspecting Dave's paycheck and keying in some numbers in his computer, tells Dave his overdraft protection limit is set to $4,000. Dave was, of course, shocked. He asks Tom why he can't have $8,000 as overdraft protection limit like Maria. Tom tells Dave that since he is self-employed, there is no guarantee he earns $8,000 every month. On good months, when there are many projects in the pipeline, he might earn $8,000, and on bad months, especially during summer vacations and holiday times, he might earn nothing. Indirectly, Tom says Maria is a fixed character column and Dave is a variable character column. The banking application took these into consideration for evaluating risks and decided to limit the overdraft protection to $4,000, possibly assuming Dave earns an average of $4,000 a month when averaged over a year. Now you know the reason why the optimizer estimates row size of 2015 bytes for character 2000 base tables, while nearly half 1019 bytes for varchar 2000 based tables. Generally, people don't fill in the varchar column in full, and giving them full memory might be inefficient use of the limited memory available in the server. If you are to bet now, which will you choose? Average data in a varchar column is 10% full, or 50% full, or 100% full in this planet Earth? I tell you, as a safer bet, most people will side with 50%. Of course, Dave doesn't give up. He tells Tom that he got Enterprise Edition and that he paid more money. Tom calls his manager, let's call him Matt the manager, and apologizes for disturbing him on his vacation and explains him that he got a difficult customer, Dave, and the self-employed Dave is not happy with the overdraft protection limit and that he claims to have an enterprise. Matt apologizes for leaving Tom alone on his new job on the very first month and asks Tom what he means by an enterprise, mentioning that we are all enterprise. Tom tells Matt that Dave has paid more money to buy the enterprise. Matt replies, Tom, now I know what you mean, the Enterprise Edition. Tom, these people are out of their mind. They buy a business class ticket and expect to fly faster than the economy. They want to reach the destination earlier than the people who bought the economy ticket. We can give these business class passengers special meal, wine directly from Italy, cheese from France, chocolates from Switzerland, but we cannot fly business class faster than the economy. The engine is the same. Back to business. You remember those discussions from the historic days where a developer asks an expert, are there any disadvantage of using varchar data type in place of char data type? The usual answer to this question goes like this. Disk storage size of the char is equal to column declaration size and not based on the actual length of data inserted. On the other hand, the disk storage size of varchar is the actual length of the data inserted plus a very small fixed overhead. If the actual length of the data inserted varies considerably, it is optimal to use varchar data type, as it not only saves disk space, it also keeps the rows compact, which makes disk reads efficient by packing many rows in a single page. But there is one penalty. If the varchar column is updated and the new length of the data is larger than the initial data length, and if there is no space in the current page, SQL Server has to move the row to a different page and place a forward pointer in case of heap table, causing non-optimal performance, or split the page in case of cluster table, causing fragmentation, leading to non-optimal performance. The developer replies that he or she has no plans to update the column with larger data length, and the expert gives the blessings to use varchar data type. What they missed is, in few cases that might matter to you, even if the data was never updated after insert, varchar column can perform suboptimal in comparison with char column. Yes, suboptimal. Instead of telling this over a PowerPoint slide bullet point, I showed you how in some cases varchar can be suboptimal by using the example top 7 char and top 7 varchar. These issues have been with us for more than 10 years. You might wonder why no one told you these things before. Personally, I spend most of my time performance troubleshooting at customer site. Whenever I notice an issue, I package that into my workshop. That is how I make my workshop into a real world experience, by regularly updating the content. I have a running list of content to add to my workshop after every consulting assignment. You can see my performance troubleshooting consulting assignment to my workshop delivery ratio from my schedule that is available at SQLWorkshops.com/schedule. Next time you plan to attend a training, ask the instructor about their performance troubleshooting consulting assignment to knowledge transfer ratio. If an instructor primarily goes from training to training, conference to conference, without real-world performance troubleshooting experience, you can expect only theoretical content, outdated content, and you will never know about these critical real-world issues. I will show you a shortcut how to correct the issue. Simply row compress the table 7 car. Let's go to the table creation. Let's drop the table 7 car. Let's create this table with data compression equal to row. When you use data compression equal to row, SQL Server stores the character data type as a varchar data type at the storage level. So let's create this table. Let's switch off the include execution plan. Let's insert 3000 rows into this table and update the statistics. And finally, let's execute the query. You see the performance is still 15 milliseconds. When you compress a table, SQL Server stores the character column like a varchar column on the disk, so you get all the advantage of varchar column. On the other hand, the optimizer thinks the column is a character column and allocates the right amount of memory, so the sorts in fact happen in memory. But there is this case when you update the column with data larger than the initial length, you run into the same issues like varchar column, forward pointers on heap, page split on cluster table, leading to non-optimal performance. So the old advice still applies. We just enhanced that advice by using a character compressed column instead of varchar column to have reasonably good memory estimation, so the sort happens in memory.